The trick to understanding free energy is to understand how it keeps time, because it's all about time that makes free energy free. First of all, it's a standing wave, and a standing wave, by definition, the current is inverted relative to the voltage. Now, since we know current is not actually current, it's a fiction, it's a form of mathematical shorthand notation to represent reactive voltage, because it's reactive voltage divided by resistance, so it reacts due to the resistance. It changes. That's how we get voltage drop. While the other voltage, voltage squared divided by resistance equals power in Ohm's law, the other voltage is applied voltage, and that's, of course, the static pressure that either pushes or pulls, depending on whether it's a regular wave that returns on every half cycle to its source, or a standing wave that never returns. What goes up continues to go up and never comes down. And this is because of the reversal of applied voltage divided by resistance, namely current is inverted relative to voltage. So in a standing wave pattern, the cycle time is no longer one cycle, it's half a cycle. And the turning point for that is at the quarter cycle point, because that's where inductive reactance and capacitive reactance go in opposite directions by a full 90 degrees, creating a full half cycle of opposition between them. But it's at right angles to the initial start of that wave, which is at 90 degrees, at the quarter cycle point. So when that happens, it's already marked itself for early retirement, so to speak, of that cycle time, so that at the quarter cycle point, when it inverts and creates the inversion of current relative to voltage, it's already marked the half cycle point as the termination of that cycle. Now, because it keeps doing this at every quarter cycle, it keeps subdividing the cycle. But it does so at the quarter cycle point. It never reaches beyond the half cycle point before it starts the next cycle, subdivided by that, and goes as far as the quarter cycle and then inverts itself, and then goes as far as the half cycle and starts the next half cycle. So it keeps subdividing cycles of time by half, starting with the quarter cycle of that next cycle and terminating at the half cycle point. So it never goes beyond the half cycle. And so as the frequency keeps doubling, oddly enough, the amplitude also keeps accumulating. And it's not by doubles. it's logarithmic. It's hyperbolic, or it might be a huge vertical ascent or descent into the positive or negative direction away from the midline of the oscilloscope tracings. Because it's a standing wave and it has zero voltage, it has 0 watts, because a reactive load, namely impedance, does not see the wave. The wave is invisible. The standing wave is invisible as far as impedance is concerned, because impedance is the one creating it. It's the one creating the standing wave conditions. So of course it's not going to see it as offering itself as resistance. Instead, it's subdividing the wave. It's subdividing the cycle time at the quarter cycle point. And so the impedance never sees it because it's busy aiding and abetting it. You know, if you're aiding and abetting a criminal, how can you judge the criminal? You can't. You're aiding and abetting him. How can you judge him critically and say, hey, you're doing something immoral? No, but here's some help. You'd be a hypocrite. Well, the wave's not going to be a hypocrite any more than you will be. So if you're helping the wave decrease its cycle time and increase its frequency, you're not going to offer resistance. Now, so the only resistance that's offered is plain resistance, simple resistance, because it has nothing to do with impedance and reaction, electrical reactance. But capacitive reactance and inductive reactance as impedances are aiding and abetting this wave to do its magic, and so they're not going to see it by offering resistance to it. They're going to offer no resistance. They're going to be helping it to subdivide itself. In a sense, you could say it's the maximum resistance they could possibly offer by altering the wave in such a manner that it's no longer a wave in the real world. It's a wave in the complex world, in the imaginary world, due to the fact that the current is inverted relative to the voltage by 180 degrees. But in order to get to that state, the capacitive reactance and the inductive reactance have to shift by 90 degrees in opposite directions simultaneously. There can be no time lag. This is why parallel capacitance within an inductor is so vitally important, because it converts back EMF into reflectivity of current. So current is no longer kicking back after it had already gone forward with a time delay between the two. And the kickback is not a partial kickback, it's a full reversal, simultaneous to the application of voltage. So the reactive voltage due to resistance and the applied voltage driving the applied voltage in the inductor. Those two things happen simultaneously, but in reverse directions. So back EMF has magnified, so that to the point that it's now parallel capacitance. It's no longer back EMF. It has converted itself into parallel capacitance of an extreme degree. I've only done a few experiments with parallel capacitance within inductors, but the first time I had to use 1e to the 20th power, 1e to the 20th farad of parallel capacitance in the inductor. And then the second instance, I had to use 5e to the 8th, 5e to the 8th, to the positive 8th. So that's 5 followed by 8 zeros, which would be slightly less than a giga, wouldn't it? It would be 500 million, wouldn't it? Yeah, 500 million farads, which is a lot of farads, considering the fact that usually we don't go beyond, 1, 10, 1,000 if we're lucky in supercapacitors. But it is possible to achieve such a high level of parallel capacitance within an inductor. We just haven't investigated the techniques, such as Nathan Stubblefield did, the Amman brothers did, and who knows, possibly Tesla. We just don't know that there are techniques for achieving that kind of high, elevated parallel capacitance within an inductor. But you do need an elevated capacitance to get that's the magic, to get the back EMF to turn into a reflected reactive voltage divided by resistance, rather than a kickback of EMF that would have involved a time delay, and then you don't get the reversal of current like we want to get in order to get a standing wave. So when the standing wave is like that, and there's no impedance, only resistance offered to it, and the impedance is helping it, and it even lives off the resistance, because this is Mohs law now. This is no longer Ohm's law. This is where we get superconductivity at room temperature, because instead of voltage squared divided by resistance giving us power, we get resistance divided by voltage squared giving us superconductivity at room temperature, superadmittance. And should be measured in Mohs, not Siemens, because it has nothing to do with jerking off. It has to do with the multiplicative and additive inversion of Ohm's law. So both the numerator and the denominator flip, they change places, and it also gets negated because of the partial negation between capacitive reactance and inductive reactance, both contributing the square root of -1. And we get the square root of -1 squared, we get -1, which is the inversion of current. So because impedance is no longer impeding, but assisting the maintenance of this standing wave, you don't have to have an input of power above and beyond what you initially gave the circuit. All you have to do is stay within the limits of what the environment provides. Mother Nature gave us all the energy we need for free energy, and just the right amount, in the order of 1 or 3 microvolts. That's the ambient voltage in the atmosphere at ground level. And That's how much it takes to power a crystal radio set from the 1920s with a little whip antenna, a piece of wire 1 yard long. You paste it up against your wall above your crystal radio set, and using nothing more than maybe a coil and a galena diode and a pair of headphones, you get to bring in a radio station, faint, but you bring it in because the power coming from that radio station is all that's required to run that crystal radio set. Well, that's the same amount of power that trees broadcast and receive back and forth, because trees make the greatest aerials. You should try it sometime. Take a transistor radio and plug it into a tree using a bare iron nail, not copper and not coated with epoxy resin, but a bare iron nail. Hammer it so you get into the sap underneath the cambium, the bark of the tree. So you make contact with the earth. So now you've got a grounded aerial, and the structure of the tree is a perfect aerial. It doesn't even have to have leaves on it. All it has to do is be a living tree, and it'll suppress static background noise and boost the signal of your station that you're trying to tune into, and you'll get better reception than using the built-in antenna alone inside your transistor radio. Anyway, so since impedance is no longer impedance, we always think of impedance as a form of reactive resistance, but now it's actually altering the behavioral characteristic of a wave to turn it into a standing wave, and that's all you have to do, because when it's a standing wave, now it doesn't see reactive forces as being impedant to their flow, so they don't die out. The prior ripples of waves, because they're a standing wave, do not die out. They retain themselves. And the new ones come along and accumulate on top of the prior ones. And the only impedance, so to speak, is not impedance after all, but merely resistance. And so the object in question, let's say it's a coil of wire, starts to heat up, and it gets very hot, and the insulation melts, and the whole thing shorts out, fizzles, smoke rises, and you no longer have free energy rising to infinite oblivion of the circuit. So it has to be regulated. But be that as it may, the cycle time is halving itself, so the frequency is doubling, but the amplitude is not. The amplitude is increasing at a hyperbolic rate. And that hyperbolic function may be so steep that we may not even see a nice curvature to that hyperbolic function of amplitude increase. It could be a vertical ascension or descension in the negative direction away from the midline, whatever. It is so fast because it keeps speeding up. Because the waves, when they accumulate on the basis of the frequency. And as the frequency doubles, the amplitude doesn't just double. I'm still not sure of the mechanics of this part, but just because the frequency is doubling doesn't mean that the amplitude is doubling. I've seen the amplitude. Well, no, let me go back. It does double. Excuse me. The amplitude does double per unit time. But that's the catch, per unit time. And so sometimes using a higher frequency is better, but sometimes using a lower frequency is better. The thing actually amplifies faster at a lower frequency. I'm still not sure about this. There's some holes in my awareness, but the fact is, the beauty of the thing is, once you get the thing started and you maintain its standing wave condition, all it can do is accumulate energy. It can't do anything else. Unless due to intermittency, you don't create the standing wave continually. Then it matters when in the cycle do you invert current relative to voltage. If you do it prior to the half cycle point, the peak or the trough, then no. That's the 90-second. Oh, my God, that's right. Oh, I never realized that. Yeah, the peak and the trough of a wave is the quarter cycle point. That's right. So if you do it just prior to that 90-degree shift, 90-degree intrusion into the cycle time, then you will get the magnification of the wave. But if you do it slightly after the 90 degree point, the quarter cycle wave point, you actually get a disappearance of amplitude. It just disappears. And basically what it does is the amplitude shrinks or it expands. And so what it means is we've wiped out some of the waves versus allowing them to accumulate. And what that means, if they wipe out, what that means is we've lost the inversion of current relative to voltage at the wrong period of the cycle time, so that the waves have come back together. The current phase of energy and the voltage phase has come back together again and synchronized itself. And so now reactive impedance is acting as a resistive force instead of aiding and abetting the accumulation of energy due to the inversion of current relative to voltage. When I say inversion, I mean 180 degree inversion, not 179, not 178, but 180 degree inversion of current relative to voltage. That's what I mean when I use the word inversion. Okay, I've covered all the main points, so we still don't know why it accumulates at different rates. That's something I still don't know in any case. But nobody studies this. I've spent a few years now, not too many, over 4 years studying it on simulators. And so I get to become familiar with the mechanics, the wave mechanics. See, if a wave doesn't move, the energy composing that wave, which always moves, cannot leave the circuit by way of conversion, coming out as heat, light, or mechanical motion. It can't leave. All it can do is accumulate. This is very vital to understand because energy is always moving, right? That's conservation of energy. But waves have nothing to do with conservation of energy, and waves regulate what happens to the energy. They determine what happens to it. If it's a standing wave, the energy is not going to leave the circuit. It's just going to accumulate. But if it's a moving wave, the energy now can leave the circuit. It can also enter the circuit, but only if it's a moving wave. So waves themselves are not energy. They are made of energy. For instance, you do a wave in a football stadium, you stand up and you sit down. That's energy. But the wave traveling around the stadium is not energy. It's simply information. It has nothing to do with energy. Energy causes that wave to move or to be a standing wave and stand still, but it's only because of how the energy coordinates itself that determines the outcome of whether the wave moves or whether it stands still or does something in between. So it's a little more complicated than just conservation of energy alone, would physicists would have you believe, is the end-all of discussion of the subject. It is not. It hasn't. It's like the feet you stand on, So what? Okay, we all got feet, but what are they doing? Are they walking backwards, forwards, opposite directions simultaneously? Because that's what energy does when you have a standing wave. You got one foot going forward and the other foot going backwards. I mean, literally, when you get reversal of current, it is so bizarre. Because normally we think of wind moving from areas of high pressure to areas of low pressure to equalize the pressure within those two geographic areas. But with reversal of current, you get the complete opposite. You get wind blowing towards areas of high pressure, depleting the areas of low pressure and bringing them down to zero pressure. And yet it still moves because it's not the pressure pushing the wave anymore. Now it's the pressure in the high zone that's sucking the wind or the current. It's no longer being pushed, it's being sucked. And so that's why you don't need pressure at the source anymore, because it's not the source. It's the area of high pressure that's the source pulling the current into itself. Hey, physicists call it a black hole. It has nothing to do with their definition of a black hole. But trust me, it is simply a star that has become so completely reactive that the current is reversed to voltage by 180 degrees. That's why we have a black hole. It has nothing to do with mass accumulation. Oh, gravitational forces, humongous. Inside of every star, and every star is hollow, just like the planets, is a dark star. And the Nazis worshipped the dark star. They called it the Black Sun. It had 12 arms, and they were going in reverse direction to the normal swastika. And this is the source of energy, is a spark gap that never fires. It remains there, quiescent, but it ionizes, but it doesn't arc. And that's what a dark sun is. And it normally fuels the outer photosphere, which is a spark gap that has turned on. So the photosphere of the planet Sun, our Sun is a planet made of calcium ferrite, and it's a hollow shell, and it has a dark sun on the inside that does not light up, namely a spark gap that does not arc. But the photosphere that we see is an oceanic plasma of two layers of silicon plasma and neon plasma. So we are literally lit up and heated, and the energy of our planet is run by a huge neon sign in the sky. And some of the silicon comes out of the calcium ferrite and contributes to that neon. So we have both silicon and neon as a plasma. So that's the arcing spark on the outside, but it has an inner spark that's quiescent. It's not quite on yet. It's just humming with mild activity. But that's the source of the inversion of current relative to voltage. And so on the inside of the sun,